Selamat sejahtera to the Dr. Arifuddin. My name is Lo Chin Yi, and we have to present the project in the digital signal processing, which is PEJ 30603, section 3, for the semester 2, 2022 and 2023. And our title project is Design a Low-Pass FIR Filter with Arduino Uno. And this project is prepared by our group members, which is by Lo Chin Yi and Nur Farhana Arisha binti Muhammad Isnardi and Usama Apririsa Mohammed. So now Usama will present the introductions part.
Introduction. Digital signal processing DSP involves the manipulation and analysis of digital signals using mathematical algorithms and techniques. DSP has wide application in areas such as audio processing, image and video processing, communication and control system. Filters are essential components in signal processing system as they suppress or enhance specific frequencies components of the signal, remove noise and extra relevant information. The project aims to design a microcontroller-based digital filter simulator using a microcontroller board like Arduino. We use now Arduino Uno to demonstrate filter design and signal processing concepts. Still, our introduction continue. Unit impulse response fair filter. The one we have now, we have designing a low pass filter. Fair finity impulse response is a shortcut pair that have a final impulse response and typically designed using methods like window frequency sampling or optimal least squares techniques. Infinity impulse response (IIR) filter have an infinite impulse response and are designed using methods such as the bilinear transformer and impulse invariance or pole zero placement. The impulse response of filter representing the filter's output one and in glass signal fed into it. The filter coefficient determining the frequency response of FIR filter, and the number of the coefficient is corresponding to the filter's order or length. Window method is involved in multiplying desired frequencies and response with ideal frequency response to obtain FIR filter coefficient. The project provides a practical exploration of digital filter design, the signal processing techniques, and the application of DSP concept using the microcontroller based system.
So now for the next, which is the problem statement. In this project is to aim to design and implement a low-pass FIR filter system using the MATLAB and the Arduino Uno to attenuate unwanted high-frequency component while preserving the desired low-frequency components. So the filter system aims to enhance the signal quality and integrity by removing noise and unwanted interference. So the effectiveness of the design filter system will be evaluated by comparing the filter output signal with the unfiltered input signal using the real-time visualizations tool. Next, for the objective part, in this project we got 5 objectives we need to achieve. For the first one is to understand the theory and concept of FIR and IIR filters, and for the second is design a low-pass filter using the MATLAB to attenuate high-frequency component and preserve low-frequency components. And the third is to implement design filter on the Arduino Uno microcontroller board. And the next is to verify the functionality and performance of the implement filter by comparing the filter out signal with the unfiltered out input signal. And the last is to visualize the output result in real time using the serial plotter tools in the Arduino IDE software.
Assalamualaikum and good day to Dr. Arif. My name is Nur Farhana Arisha binti Muhammad Isnadi. My metric number is AA200067. Today I will explain to you the methodology part of our project. To do this project, we did our calculation manually and then we run our coding by using MATLAB software and then we connect it between Arduino Uno and Arduino IDE software. In our manual calculation, we use the Hamming window as the method window to design the LPFIR filter. We applied an inverse Fourier transform to obtain the corresponding time domain coefficients. This is the list of formula that we use in our manual calculation. After we obtain the corresponding time domain coefficient, we design and simulate the filter by using MATLAB software. And then we use Arduino IDE software to utilize the program from Arduino Uno, and then we visualize the output results by using the serial plotter tool. This flowchart shows the process of designing the LPFIR filter in our manual calculation. We start the calculation and then we determine the specifications for filter design. Then we determine the parameters that we need in our calculations. After that, we get the symmetrically windowed impulse response. And then we end our manual calculation. The next flowchart shows the part of LP filter design in MATLAB software. We start the simulation and then we connect it with the microcontroller and software, which is in this case are Arduino Uno and Arduino IDE. Then we define the FIR filter coefficients and we convert the FIR filter coefficients to Arduino code. Then we uploaded the coding into Arduino Uno. Then the output signal will be displayed by using serial plotter. And then we analyze the signal results. And that's the end of our simulation in MATLAB software. The last flowchart shows the FIR filter implementation between Arduino Uno and Arduino software. We start the implementation, then we design the coding, including the input values. Then we run the coding program. After that, we design a coding to plot the graph that shows the output. Then we observe and analyze the output results. That's the end of the final flowchart. So that's all from me. Thank you.
So now I'm continue to present the part which is the result and analysis. In calculations, I set the cutoff frequency which is 10 Hz, and for the sampling frequency is 30 Hz, and for the filter length, which is the capital letter N, is equal to 13. So next we can find out the filter range, which is the small letter n. We start from -6 to 6. So next we also can find the FC, which is 0.3333. For the impulse response of low pass FIR filter with the cutoff frequency, which is equal to these equations. After we substitute the parameter value, so this is the value that we found. For the selected window method, we choose the Hamming window method. For the equations for Wn is equal to these equations. So after we substitute the value, this is the value that we found. Next, for the HLP equations, which is equal to Hn multiple to Wn. So this is the value that we found. For the next step, we assume the input signal is xt, and same as in these equations. So, but we need to convert from the analog signal to digital signal, since we know that the Ts is equal to 1 over S. So now for the input signal, equation is equal to Xn in these equations. This is the Xn for the input signal value. For the output signal, Yn is the convolutions. So this is the result value that we found. For the next part, which is the demonstrations. In MATLAB software, later on we will prove that the answer in the calculation by using the MATLAB software, and we had already designed a low pass FIR filter using the Hamming window method in MATLAB software, and later on we'll show what is the low pass FIR filter response by using MATLAB software. Okay, so now we move on to the MATLAB software. So here we already add the parameter value, and we add the equations that we need to use to design the low pass FIR filter here, and this is the code that we write to show the graph. So here we run the program. After we build the coding in the stream, so we can using the command window to find the result value. So here is the value that we found for the FC, for the value N, for the H and W. So this value is same in the calculations value. After we run the program, this is the first figure that we can get, which is between the magnitude and the phase. The next figure, we can see that is between the input and output. For the first row, it shows the input signal and output signal. For the input signal, the graph is plotted a bit sharp and narrower, but after we filter it, the graph is shown a bit wider and more sequence. For the second row, it shows the input magnitude spectrum and output magnitude spectrum. Since we set the cutoff frequency is 10 Hz, so for the lower frequency is about 5, and the higher frequency is about 15. The magnitude at the lower frequency will filter out from magnitude 1 to 0.1275. So it's about 10% will be filtered out or attenuated. So means that this frequency is allowed to pass through. The higher frequency, which is 15, the magnitude will be filtered out from 5.403 to 0.894. So it's about 99% will be filtered out or attenuated. So means that it is not allowed to pass through. Since the percentage is quite high at the higher frequency, so means that the low pass FIR filter is already designed and is designed successfully. For the third row, it shows the input phase spectrum and output phase spectrum. For the output phase spectrum, we can see that the result is more sequence compared to the input phase spectrum. Next, for the demonstrations between Arduino Uno and Arduino IDE software. Between this, we later on will show how to convert and upload the coding in Arduino Uno board and using the Arduino IDE software to display what the output result that we found. So we move on to the Arduino IDE software. So this is the coding that we built to use to convert and upload to the Arduino Uno board. So before that, we need to connect the Arduino Uno board. After we connected, we can click to compile the sketch. So after we compile done, we can click the upload to the Arduino board. So the board is already show that the coding is already uploaded. So now we can click the tools and select the serial plotter. So this is the result that we get. So we can click the stop first, can see the result more clearly. The result is shown between the value 1 and value 2. The value 1 is the input signal and the value 2 is the output signal. So now we can obviously see that the magnitude is already attenuated. Since, for example, the value 1 is 3.7, later on the output will be attenuated to the 0.99. It is around 70% of the magnitude that is already filtered out. In this design for the low pass FIR filter is already success, since the percentage is quite high to perform the attenuating or attenuated signal. Now we can go back to the slide to continue the presentations.
Now I will conclude the finding of our project. As a conclusion, our group has successfully designed and implemented a filter system using DSP techniques with Arduino IDE and MATLAB. We have designed and implemented a low-pass FIR filter in MATLAB considering the desired filter characteristics. We use the Z-transform technique to analyze the filter system's behavior. We also use Arduino IDE and Arduino Uno microcontroller board for real-time implementation of the filter algorithms. The serial plotter tool in Arduino IDE enables visualization and analyze the filtered output signals. This project has improved our understanding of DSP concepts, including FIR and IIR filters, their characteristics, and coefficients impacts. Then we use MATLAB to showcase the frequency response of the low-pass FIR filter, while we use Arduino to implement the filter in real time. The serial plotter facilitated observation of signal transformations and the filter's effects on input signals. This project has enhanced knowledge and skills in DSP, filter design, and real-time implementation using Arduino. MATLAB and Arduino IDE provided a comprehensive understanding of the filter system, addressing signal degradation and exploring solutions through effective filter design and implementation. So that's all from our group. Thank you for watching.